Hey there, my name is Sherry. I'm a solution architect at Elastic, and it's a bummer we don't get to see you in person. I usually do the community meetup in our Mountain View office, so hopefully we'll get to do it soon. Nice seeing you on Zoom.
Hey, everybody. I'm also a solution architect with Elastic. And just want to thank you for coming out, spending time out of your busy day to check in with us and see what's new and cool in the Elastic Stack. So with that said, I think we'll hop right in. I do just want to say that these things work best when there are questions. And so don't hesitate to jump in and interrupt me if you have questions at all. I will be pausing from time to time, but you should feel that you can just jump right in with questions as they come. Okay, so let's get started. We're going to talk about what's some of the great new features that we've recently released in the Elastic Stack. But before we do that, just want to level set a little bit. So at Elastic, we're really focused on three solution areas. Enterprise search for application search and workplace search. Observability for all of your infrastructure metrics, monitoring, and alerting needs. And Elastic Security, which is a world-class endpoint security product to protect your Mac laptops, your Windows laptops, your Linux servers. So these three solution areas, enterprise search, workplace search is our enterprise search, organizational search. App search allows you to add search to your applications. Site search allows you to add search to your website. In the observability space, we have a number of tools, application performance monitoring for distributed tracing, log analytics, centralized metrics analytics, and service uptime. And then in security space, we have a great endpoint security product, as well as a great SIM product for threat hunting and threat resolution. Just to refresh, the Elastic technology is built on what we call the Elastic Stack. Here in the middle, the Elastic Stack is really composed of several components, the heart of which is Elasticsearch, this highly scalable distributed JSON document store and search engine. We've got Kibana for our visualization layer, and Beats and Logstash for our ingest layer. And it's important to know that Elastic is flexible in that you can deploy it really anywhere. Whether it be on cloud, on Kubernetes, or bare metal on premise, you can really run and deploy Elastic anywhere. So there are a couple of themes that we've been focusing on here at Elastic for the last several releases. And one of those big themes is simplifying the onboarding and data ingestion process. We've done a lot to make it very easy and intuitive to get started loading data into Elastic and very quickly getting insights out of it. So we just released Elastic 7.9 yesterday. And one of the big exciting features in Elastic 7.9 is the Ingest Manager. The Ingest Manager is meant to fast track your onboarding of different data sets into the Elastic Stack. As you can see at the image here taken from Kibana, we have a number of integrations with popular technologies. We can easily monitor AWS integrations or Microsoft Azure cloud integrations. We can monitor Kafka, Kubernetes, NetFlow, Apache logs, Nginx. Previously, you had to do a lot of manual work to configure log files and configuration files, but now it's as simple as one click. This is made possible by the new Elastic Agent. This is also something that we're releasing in Elastic 7.9. And I'll talk more about the Elastic Agent in just a bit. The idea behind the new ingestion and integration manager is that you should be able to ingest new log types, new data sources with just one or two clicks right from the Kibana user interface. So here on the image here, I'm doing some ingestion of Nginx logs. And I'm just clicking a few buttons here in Kibana to get Nginx logs flowing from the endpoint into my system. It's a lot easier than the old way of doing things where you had to configure YAML files. So the core technology that makes this new ingest onboarding super easy and intuitive is a new technology we're shipping with Elastic 7.9 called the Elastic Agent. The Elastic Agent is a single unified agent to collect logs, metrics, APM, security, and more. Those of you who've been using Elastic for some time will be familiar with our beats agents: file beat, metric beat, heartbeat, APM agents. These are different agents that traditionally we've used at Elastic to help ingest data into the system. And they would be installed on your servers or your laptops, your endpoints, and they would emit telemetry back to Elastic. But the feedback we got from the community was that there are just simply too many different beats. And so what we did was we took the technology and we wrapped it all into one agent that we're calling the Elastic Agent. It's a simple single binary install that you install at your endpoints, and then it's very modular. So once I have the Elastic Agent installed, I can go back to my Ingest Manager, choose the integrations that I want, and in just a couple of clicks, I can now have my agent on my Linux server or my Mac laptop or my Windows server automatically start sending back APM traces for my applications, or file or system files, or Windows event logs. It's just one thing to configure and scale. Another component of making ingest easier is, now that we have Elastic Agent, we also have the tools to centrally manage all of your Elastic agents from a single place. So we have many customers who are running Elastic agents on thousands of machines, and they need an easy way to push changes out to all of these agents and to monitor them and organize them. With Elastic 7.9, we're introducing what we call Fleet. Fleet is a way to centrally manage all of your Elastic agents. You can add integrations for your agents remotely. So maybe I have a class of agents that are all my MacBook Pros, and I want everybody with MacBook Pro to have endpoint security turned on. Well, I can go here into the Fleet Manager and easily turn on endpoint security for all of my MacBooks. Similarly, maybe I have a fleet of Linux servers, all of which are running Nginx. I might want to start monitoring Nginx there, and with just a click of a button, I can start to monitor that. So this is really powerful, and really excited to see how this goes, and it's really going to help running an Elastic stack at scale. I mentioned endpoint security. We're not going to delve too much into security in this webinar, but I just wanted to mention that a lot of people know Elastic for observability and for logging. What's lesser known about Elastic is that we really have world-class endpoint security, detection, antivirus, anti-ransomware, anti-malware. And now you can have access to that protection with just a few clicks from the user interface. This screenshot shows an example of running the agent on Windows. And you can see here that we've opted to track events such as DNS, network activity, DLL loading, driver loading, registry changes. So right here, from a couple of clicks, I can deploy endpoint security across all of my assets and monitor and manage them centrally. So we're really excited about this theme of onboarding new users, onboarding new data sources, and making it incredibly easy and trivial to manage them at scale. So the next big theme that we've been focusing a lot on at Elastic over the really over the course of this year, but more since the spring, is improving our story around alerting. Now, traditionally, Elastic has had a very powerful alerting engine built into the system, and we call that alerting engine Watcher. Watcher is what we call, it's really a power tool or super user tool. It's very powerful, but it's also very complex. And over the years, we've gotten a lot of feedback about it's not the most usable tool. And so we started rethinking how we approach alerting in the Elastic stack. And what we came up with was a totally new visual-based alerting engine built right into the user interface. It's very simple. It's a consistent experience across all of our apps. And it's really going to be a joy to work with as opposed to Watcher, which was really difficult. One of the exciting things about the new alerting framework in Kibana and in the Elastic Stack is that we have a number of really great integrations out of the box. So now as you create an alert, it's easy to integrate alerts with external systems. As you can see here, we can send alerts to a Slack channel. We can send it to PagerDuty. We can even send it to ServiceNow. And other third-party integrations will continue to come along. And you just click a tile, you enter in some credentials, and it's really instantaneous. And now you can send your alerts right off wherever you want them. So what does the new alerting really mean? Well, so in Kibana now, we've added alerting tools really to every application or every subset of functionality within Kibana. Whether you're in the metrics app or APM or the newer Uptime app or the logs app, there's always going to be an integration or an action panel right there that you could click on and very easily and intuitively start to write alerts and then again integrate them with PagerDuty or Slack or other integration points. So it's an embedded workflow and it's really easy to get started, and it's really going to take the place of the traditional watcher. With that, I'm going to hand it over to my colleague Sherry, and she's going to talk about APM.
Okay, perfect. Do you want to drive or do you, oh, you're going to drive for me? Perfect.
I'll try to anticipate and drive it for you.
Okay, sounds great. So as you know that we offer a open source APM solution, and we cover a wide range of languages, including extensively for Java, for .NET, for Python, and also Node.js, including the React and Angular framework, and as well for the Python framework of Flask and Django. And to get going with the Elastic APM solutions, it's super easy. Attach attach agent to your source code and drop a few lines of code depending on what you wanted to do. In here, you can see that this is for the Python frameworks for Django. So you could just drop in, attach the library, give your APM server's URL, your secret token, and you're ready to go. And super easy to start, and also for especially for Java and .NET, you don't even need to do anything because those are bytecode based applications. So you just have to attach the library and off you go. Everything is auto instrumented. Next slide, please. And also that we do support distributed tracing. So if you have microservices, it enable you to gain a end-to-end visibility of your application and see how each service interacts and which one is the slow method in your APM in your application stack, and also to be able to see the external calls with details, including database calls. So don't worry, the database queries are there. However, the values that in your word clause are not there. And also we offer RUM as well. Again, very simple to get started. Just embed the RUM library and then give your APM server URL and the secret token, and you're ready to go. And it gives you a great way to figure out where your browser is taking time and see what your your user interaction with the browser and various DOM objects, and to see what is taking time. Next slide, please. And the good thing with the Elastic Stack is the fact that we are enforcing the Elastic Common Schema. So whether you're coming from metric data, from your APM data, or from your logging data, there is a single Elastic Common Schema that's being enforced. And given the fact that we are enforcing the common schema, it's very easy to integrate machine learning into your data. So you can actually calculate what is anomalous response duration, the number of error rates, or anything you care to monitor. Also that one of the things that we often hear from our users, or if you're a data scientist yourself, is that you spend a lot of time transforming data into a single format, so you can actually do analytics on top of it. This way, because we're enforcing the data enforcing the data format / schema, we are able to perform ML just right out of the box.
Hey, Sherry, I have a question.
Yes.
Machine learning sounds complicated. How do I integrate it with this APM?
Oh, you don't. You just click on enable, and it's already it's pre-built. It is completely out of the box. All you have to do is turn it on, and off you go. And if you want to extend from what we provided out of the box, you could definitely do so as well. All right. And to enhance the view of our users, we are merging all of the pillars of observability into a curated single pane of glass experience. In addition, that interesting enough, you can see there's a SMS feed over on the right-hand side. You could definitely provide those feed yourself. It's just an API call. So some of the customers who, like, for example, if you are doing a maintenance and you want to let your user know, you can actually just put them on the right-hand panel here. And then you can also service any of the alerting key metric and any of the charts, and you can embed them into the single panel, so you can actually save time, just get you a quick view of what is going on, give you a sort of orientation of what is within your ecosystem, and also be able to have your user to click on any of the things that are interesting to them and take them to the specific of the metric that you're monitoring, or the message you're monitoring, or the application you're monitoring.
Right. Hey, Sherry, I have a question on this screenshot.
Sure.
I see alerts.
Sure. Yeah, go ahead.
Sorry, my phone. I see
Siri.
alerts here. Yeah, when I say, hey, Sherry, it thinks I say, hey, Siri. I see alerts here. Do any alerts come out of the box?
Yes. So some of the alerts come out of the box, just like your ML jobs. For example, the error rate, the transaction duration, those are all pre-configured for you. Obviously, if you want to create your own, you can also do so as well, and also that it's very easy to customize and extend, just like ML. And Don did ask a question here. So Watcher is no more, it's called alerts. Is that going to be included in the base distribution, or is it a level support required for alerts? So yes, you're correct. Watcher is no, well, I shouldn't say that. So your old Watcher is still gonna be there. So if you have written a lot of the Watchers, it still works. Alerts is it provides a UI, and it provides an easy user experience. Now, if you want to write something that's more complex, like for example, if you want to find out the moving average of your duration on a given date and be alerted if it exceeds 3 standard deviation, you still have to write a watcher for that. And alerts is not going to be available through the basic distribution. I think the alert is in the gold support level. Andrew, is that correct? I believe so.
No, alerts is, I think it's in the basic distribution. I'll find out in a moment.
Okay, wow, that's nice. That's excellent. Yeah. It might be in the basic, that means it's free. All right. Okay.
May I ask a question? This is
sure.
Yeah, hi. So do these alerts just specifically work with observability, or can you use it with, let's say, just standard indexes that you might have?
Yes, it works with just about anything you have. It's just that they are pre-built alerts and embedded alert interactions with the observability in the SIM module.
So you have pre-built components that we could use, but yeah, anything to do with like our own indexes is something that we'd obviously have to build ourselves. Okay.
Yes, correct.
Yeah, that makes sense. Okay, thank you.
No problem. Any other questions I can answer before moving on? No? Okay, perfect. Next slide, please, Andrew. All right. One of the things that comes with APM with the Elastic APM is the service map. So if you have microservices, one thing you want to find out is that, what services depends on other service. So it gives you kind of a nice dependency chart. So where the service is making call to another service. So, if you're troubleshooting, it gives you an easier way to track down what is actually causing issues. And in addition, as you can see here, there's some of the durations, requests per minute. It's a lot of the stats, and then how the CPU is doing, how the memory is doing. All of those are available at your fingertips as well. All right. And the cool thing with the service map, again, is that because, again, we're enforcing the common schema, so we can actually run out of the box machine learning jobs on top of it. The machine learning in this case will be very much the anomaly detection over time series data. As you could tell, that APM, logging, metrics, these are all time series data. So we'd be able to, detect a pattern, learn a pattern, recognize a pattern, and build a model around that pattern, and then predict out a little bit time into the future to see what the expected value is going to be, and then build a distribution based on those expected values. So anytime you're on the ends of the normal distribution curve, we could actually say, well, that doesn't look quite normal. You probably want to take a look at what is going on. And then based on where you are on the distribution curve, now on the outer band of the distribution curve, obviously you're going to see red, and then a little closer to the center, it's yellow. And then if you're just right about where you should be, then obviously it's green. So it really makes reducing time to detect issues and resolving them easy. All right, moving on. So, and also that we're going to have this actually is going to be a little bit in the future where we are going to let you customize your view. So you could actually put your span type, your transaction array, your duration and request per minute into a single pane of glass. So, you could correlate issues quicker. So it will give you the exact time span, the same transaction, the same trace. So you could see all of them at a one go. All right. And we have a open telemetry exporter now. So with the 7.9 release, we have a open telemetry support. We provide open telemetry support. As you know, that open telemetry is the, the merged result of open consensus and open tracing. So open telemetry is the way of the future, and we officially support open telemetry. With the open telemetry support, you are not going to experience any vendor lockdown. So you could choose to use the Elastic APM or any other APM solution out there. And the Elastic collector collects data from open telemetry and then ship that into Elastic APM server. And then you'll be based in the server will ship the data into Elasticsearch, and then you will get a nice waterfall view just like you have before. All right, moving on to the next slide. All right, let's talk about logging. So logging is a big use case for Elasticsearch. So the cool thing with logging these days is that you could actually, there's a capability to search through your logs, and then you could actually view details and then view context. So basically view context is just that it drill down to that section that you care about, either by time or by other contextual information that you are using. And then you could also view detail, which means just haul out that particular document and then give you the detail to it. So give you a lot of flexibility there. Okay, moving on to the next slide.
Hey, Sherry, just one thing I wanted to call out on this screen.
Sure.
If you see the top right, there's a button that says Stream Live. So what this view allows you to do is a real-time streaming view of logs across your entire organization. Whereas, in the old days, you'd have to log in, get an SSH shell on different servers and do a tail-f. Now you can essentially do a distributed tail-f across all your assets as they stream in, and then filter for certain event types. So it's really powerful for debugging. Another thing I wanted to call out is that APM is also integrated with the log viewer. So when you're in APM and you want to investigate an error, or maybe a stack trace, you can click on that and you can go directly into this log view to see the context of the logs that led up to that error.
Awesome. Down asks, can you adjust the column yet in Kibana searching and logging? And I am looking at my own instance. I don't think you can yet, but I will put that in as a enhancement request. That is a good one. I do agree.
Yeah.
And then
yeah, that would be good.
Yeah, that's a good one. But at least that, you know, with the new, I don't know, you have played around with the Discover panel lately. That has a lot more flexibility of hiding columns and adding columns now, even though you still can adjust the column width. I do agree that would be a good feature to have. And one of the things that we added to the logging UI is anomaly detection. So as you could see here, you could actually few things that you might be interested in with logs. And so one thing is that if you're not getting any logs, perhaps something is wrong. If you're getting too much logs, perhaps something is wrong. So here it actually tells you, at a given period of time, how many log event messages you should be seeing, and if you are not seeing as many or you're seeing too many. And then on the bottom, they actually give you kind of the log messages that you should be seeing. And then the other thing is that, this is the anomaly on logging rate, and also that you could take a look at the log categorization. So what it does is that it recognizes a pattern of your logging events. So if you have never seen that type of log messages ever before, perhaps you want to take a look at it. It might be signaling something that is seriously wrong, like your application is not working well, or you have network trouble, or actually, worst case scenario, you're getting hacked. So you're getting weird log messages. So that's definitely something that you want to take a look at. So yeah, again, just making using logs easier by providing the machine learning capability on top of the log events. So next slide, please. And the other thing we have now, I think that, if you release back in 7.3, I believe that you could upload a file, a data file, for example, that if it has some sort of regular format, and you'd be able to upload it like a CSV or tab delimited, or some sort of delimited file, and it will give you, it will upload the file and put it into an index for you. So with the new release, you could upload up to 1 gigabyte of file. And I think the limit before was 100 megabytes, so it was a little bit tough. Now 1 gigabyte would be a decent sized file. And then once the file gets uploaded, it actually spits out the file beat YAML configuration for you, as well as the ingest pipeline for you. So if you have a file that has some sort of pattern, you really don't need to do any grok. It just automatically does it for you. So it's kind of a neat feature. So it will go from unstructured log to index data in no time. So moving on to the next slide. Now so if you have a very formatted log, that's great. So you could parse that no problem using the ML intelligence. But often people will have things like syslog, for example, which requires some if then else block. So what you could do is that we actually have a UI now, so you could create a ingest pipeline that way you could use various graph processor. One of the best things I like about this is that you could actually test it. And then you could say that on failure, this is what I wanted to do. So give you kind of a flexibility of writing your grok filter or whatever filter you'll be using, and without actually struggling through it in the dark, or using the grok incrementer if you are remember back in the day. Okay, moving on to the next one. Next slide.
Hey, Sherry.
Go ahead. Yes.
This looks like some of the same concepts as Logstash. Using this ingest pipeline, can I get rid of Logstash?
Yes and no, it depends. So in general, yes, you could get rid of Logstash. You don't need to use Logstash just because you want to ingest data and then be able to parse them. Now, there are in certain use cases where you do want to use Logstash. For example, if you need to do read data out of your RDBMS. So Logstash provides a JDBC connector, so you can actually read it out of your Oracle or your SQL Server. And in addition, that if you need to do multi-document merging or calculate an average or merging documents together, then you probably want to use Logstash for that kind of heavy ETL operations.
I see. Thanks.
All right, so let's move on to the next slide. So log pattern alerting. So you could actually write alerts right out of your log UI. So you could actually say, you could give it a name, give it a tag, and define the condition where you want alert to be raised. So you could say when, and then what is the condition, and then you could say with the condition. You could define multiple with conditions, and then give it a time. And this will trigger a Kibana alert action. And then as you can see that out of the box, we have integration with Slack, ServiceNow, and anything that is not supported out of the box. Obviously, you could write your own webhook, as Andrew said earlier. Okay, moving on to the next slide.
Do you want me to take this, and then you can do the machine learning? Okay.
Yeah, I can.
Thanks for that. Any questions on what Sherry just went over? No? Okay.
Maybe small question. Sorry.
Yeah.
By machine learning, do you mean mostly anomaly detection or only anomaly detection, or is it possible to connect any other ML algos? Well, I don't know.
Sure.
So what do you mean?
That's a great question. After I discuss Kibana, Sherry's going to go back and discuss some of the ML advancements and improvements. So can we just pocket that until we get to it in a minute?
Sure. Thank you.
Okay. Yeah. So I want to quickly go over a couple of the things we're focused on in Kibana. If you've been a long-time user of Elastic and Kibana, you know that there are a dizzying number of ways to visualize data. We have a time series visual builder, we have timeline, we have histograms, bar charts, heat maps, geo maps. What we're trying to do in Elastic is simplify that. And we really want to make it more like kind of like a Tableau experience where you can just drag and drop different attributes into a screen to get really fast visualizations. So what you're seeing here is Kibana Lens. And the idea here is you start dragging in fields into Kibana Lens that you want to visualize. And it does most of the work for you. So you don't have to like define the x-axis or the y-axis. And it also auto-suggests alternative representations of the information. You can see at the bottom, it's suggesting a bar chart or an area chart. So Kibana Lens is where we're going to be investing most of our visualization work going forward. And we're pretty excited about it. We think it has a lot of potential. So keep an eye on Lens. Another great thing we've done recently in Elastic, aside from adding some cool new visualization types like this tree map you see on the left here, well, we've added a long time requested feature, which is drill down. You can see the animation on the right part of the screen where the user is selecting part of the graph, and then there's a pop-up window that says drill down to filtered dashboard. So he's actually selecting a time range, and then he's pushing down into a different dashboard, which gives him a different view of data, pre-filtered by that time range. You can also use this to drill down to a log view. So go from a dashboard to a log view. So this has been a long requested feature in Kibana, and we think it just adds to the usability and making that workflow of investigation a lot simpler. Another thing, we've touched on this a couple of times, but I think it bears repeating. So as you think about the various things you can do with the Elastic Stack, be it APM or log analytics or service uptime monitoring or doing cybersecurity threat investigation with our SIM tool. If you think about it, there's a unifying theme here in that we are powering all of these different tools with an underlying machine learning engine. And so what you started to see really in 7.7 and more now in 7.9 is all of these different applications are powered by our machine learning engine under the hood. And so when we're talking about SIM, for example, we have powerful machine learning algorithms to identify potentially malicious behavior. In the logging workflow, we're automatically categorizing log messages for you, and we're automatically bubbling up to you unusual log messages. In the APM space, we're doing unsupervised anomaly detection. So the point I really want to make here is, as we invest in these new tools to help you do your job better, we're also powering the new tools with machine learning to help prompt you to where to go to look for insights. And it's a real time saver, and it really helps to drive that mean time to resolution down when you have an intelligent engine kind of giving you hints of where to look, of where things might be a little bit out of whack. A great example of where we're bringing machine learning to use in the stack is in a newer observability offering that we have called Uptime. If you haven't played with Uptime, I recommend checking it out. What it does is it allows you to monitor TCP or HTTP endpoints for service uptime. As you can see, you essentially give it a URL or a TCP endpoint, and we connect and we ping that endpoint, and then we try to do a little bit of intelligence on it in terms of is it going up or down. Now, what's exciting about this Uptime tool is that we're evolving it to do more sophisticated things, like we're thinking about maybe doing some synthetic monitoring, so simulating or emulating browser workflows. So Uptime is an increasingly powerful tool that's part of the observability suite. And like everything else, it is powered by machine learning. Another exciting thing that we've added to Kibana in recent releases is our enterprise search tool, specifically our workplace search tool. So a lot of people don't know about Elastic Workplace Search. So let me just explain what we're trying to do here. Workplace search is a new take on the traditional enterprise search, where you would have a tool which may be connected to your Microsoft SharePoint, or maybe connected to your Salesforce or your GitHub, to make and index all of that to make a repository for the enterprise to find knowledge. And so what we've done at Elastic is we've integrated that same concept right into Kibana. And so now from the same tool, you can do document search across your organization. We've started using that here in-house at Elastic, and it's really proven to me to be really valuable. So I go to our internal workplace portal at Elastic, and I can search across GitHub, I can search across Jira, Google Drive, and a number of other places. And it's proven really useful to bubble up institutional knowledge that I didn't know about, but it's relevant to me to do my job. So workplace search is a very exciting new addition to the products, and we hope that you'll try it out now that it's built right into Kibana.
Yeah, so I do have a question here from Don. Is alert free? I believe third-party integration is not, but otherwise it is. So if you want an integration with ServiceNow, PagerDuty, and Slack is probably not free, but otherwise it is. Okay, let's talk about machine learning. So the Elastic's machine learning has started to support supervised learning. So one of the things that we want to be able to provide you is supervised learning in addition to anomaly detection over time series data. So currently, out of the box within Elasticsearch, we support regression analysis, binary categorization, and I believe unsupervised outlier detection. Next slide, please. So one thing we want to be able to do is enable Elasticsearch as a machine learning pipeline. So it is an end-to-end learning capability, and you could actually bring the data into Elasticsearch, construct your data set using data frame analysis, be able to convert it, transform that data into something you could use and train a model, validate your model, and finally be able to use that model for prediction. Now, we want you to be able to do this within Elasticsearch so you don't have to spend all your time converting one data format to another. And that's, do data science as you do data science instead of doing data science, so you could do ETL. So we want you to be able to make that transformation easily within Elasticsearch. Now, but at the same time, we also want you to be able to plug into any stage within that pipeline. For example, if you already have your own data set, it's already in the correct format, you could bring it into Elasticsearch and run your training model there. Now, if you have your own model, what you could do is bring that model in as well. So let me introduce you to Elan, which is our, if you work in Jupyter Notebook, if you work with Panda, this is going to be a very much Panda-like experience. So if you get a chance, please check out the Elan APIs as well as the GitHub repo. This is what we use to develop our machine learning models. And within the Elan, you're able to bring your own model in as well. So currently the model we're supporting is the library we're supporting are sklearn, LightGBM, and XGBoost. So these are currently the model that you could bring your own and be able to use them as inference. You actually could put your data into Elasticsearch, take your own model, and be able to make that inference. Now, this is not currently available within Elasticsearch. You have to do this in your Jupyter Notebook and use Elan. But in the future, we want to be able to bring this to you as part of Elasticsearch. So you could actually train a model, validate a model somewhere else if you want, and just bring the model in and make that inference based on the data that's coming in through Elasticsearch. Does that answer your question? I think someone asked earlier about bringing your own model.
Thank you. Okay. Maybe small additional question. Maybe if I want to retrain a model, I need to do all that all those steps again manually, right? So no way to do some automated kind of feedback regarding I understand that probably you will do that next. just asking, what is the flow to do? So you train, or you bring your own model, and then you have in those predictions, right? Right?
Yes, that's correct. So out of the box, Elasticsearch supports regression and binary categorization, also outlier detection. So if you are using any of those models, it's supported out of the box within Elasticsearch. Now, if you want to use things like XGBoost or sklearn, then you have to do that in Elan.
Yeah, I was just concerned that even those standard algorithms have some additional parameters that need to be configured properly, right?
Yes.
So yeah, so it's some kind of iterative way to get a well-trained model, right? And
yes.
And if you okay, yeah, I got roughly the answer. Thank you.
All right, no problem. Good. And I think that should be it for supervised learning. I'll turn it back to Andrew to talk about Elasticsearch, since Andrew used to be a Elasticsearch developer.
Thanks, Sherry. So this is the last part of our presentation. I wanted to go over some important things we've done in the core engine of the Elastic Stack, which is Elasticsearch. The first thing that's really exciting is starting with version 7.7 of the Elastic Stack. Elasticsearch now is much more efficient with how it handles memory. As you know, in Elasticsearch, data is organized into indexes. And every index that's in Elasticsearch requires some amount of overhead to be loaded into the Java heap. And traditionally, that was kind of a significant amount of memory, actually, and such that for every index that was open, you need a certain amount of storage in the heap. And this could limit really how many indices you could manage in one Elasticsearch node. Traditionally or historically, that heap to storage ratio was about 1 to 600. So every gig of heap, you could have about 600 gigs of index space. Now, as of 7.7, that ratio is about 1 to 4,000. So we've significantly reduced the amount of memory in the Java heap that needs to be resident for each Elasticsearch index. This is a great graph showing exactly what happened. This graph here is available on our public site, benchmarks.elastic.co. And this shows before 7.7 and after 7.7, the memory consumption in the Java heap for an index. So whereas previously, if we wanted to manage 10 terabytes of data in Elasticsearch, it would require about 17 gigabytes of heap just to keep those indices open. Post 7.7, we only need about 2.5 gigabytes of heap to store 10 terabytes of data. That's really significant because it means now all that heap space is left over for us to service queries, do aggregations, service concurrent queries. A lot more is possible now that we're much more memory efficient. So if you're not on 7.7 or later, we'd love you to upgrade because we think this is going to be a big improvement for you.
Small question.
Yeah.
Is it mostly because of more efficient storing that in memory? I mean, same dynamic mapping or kind of same static mapping for same data indexed in 7.7, right? And pre-order that 7.7 is much more efficient just because of more efficient storing that, right? Or you changed the dynamic mapping as well, for example, and the indexing less probably.
No, we didn't change the mapping. This chart shows the exact same data with the exact same mapping.
Mm-hmm.
So it's not space saved by indexing less data. It's indexing the same amount of data. A couple of things that we've done is we're always making the data structures more efficient. But also there's been a long-running effort in Elasticsearch to move more of the data structures out of the heap and onto directly memory mapped storage, which means that the heap can stay free for transient Java objects, but the bigger data structures now can be memory mapped by the operating system into the buffer cache, or sometimes called the page cache. And so you get memory access to on-disk structures, but they don't pressure the Java virtual machine and cause more Java garbage collection. Does that make sense?
Yeah, that makes sense, but does it actually mean some kind of fragmentation when, so you're splitting native versus Java heap memory, right? And it sounds like you are reserving some memory, native memory to store some, well, to not stress garbage collector or some kind of that, right? But what's, just about fragmentation probably, or splitting that memory, splitting brain that way.
Fragmentation in what sense?
I mean that probably natively you will reserve some memory, and it will just be kind of will stay not occupied that much, or you will adjust native buffers if likely. And I mean fragmentation. Well, not fragmentation, but probably you need to split your memory between Java heap and native memory, right?
Yeah, that's correct.
And so is it just a matter of proper capacity planning and just configuring what amount of native memory your nodes will need, and what amount of Java heap memory you will need? How will user decide how to balance those amounts?
That's a good question. Our general rule of thumb is to size the Java heap at about 30 gigabytes. The exact number varies depending on the JDK version, but we want to always size the heap so that we can use compressed pointers. So on a 64-bit machine, if we have the heap at 30 or less, we can actually use 32-bit pointers, which gives us less space, more space for data and less space for bookkeeping. Now,
Sure.
so we say the rule of thumb is that give half the physical memory to the Java heap, but not exceeding 30 gigs. So what this means is in a 64 gig machine, you're setting aside 30 for the Java heap, and then you have 34 for the operating system plus for the page cache to memory map on disk pages into memory. Now, the same applies if you have like a 128 gig machine. You're still going to have 30 gigabyte of Java heap, but now you have much more physical memory to memory map the index structures into memory. So there's less paging in and out.
Got it.
Does it make sense?
And regarding yeah, sure, thank you. And regarding memory management, if garbage collector is doing the work for you for Java portion, how do you manage native portion of that?
Well, we don't have to manage it. It's the operating system manages it. So we just access the on-disk files. We request the operating system to memory map them. And then the operating system knows how to page in and page out unused and recently used pages on demand. So we don't actually have to do any explicit memory management. It's not like C or C++ where we have to deallocate pointers.
No, not in that sense. I was just meaning that. So that what is allocated in native memory, it is never freed, right? It is just all alive data, right? And no need to collect that.
Yeah, no need to collect it.
Got it. Yeah.
Yeah. Cool. Good, great question. One of the final things I wanted to touch on was now Elasticsearch supports a new asynchronous searching model. It's a new REST endpoint called Async Search. And the motivation is that as people put bigger and bigger data sets into Elastic, not every query is going to return in sub-second. As you take a year's worth of data and you maybe want to do an aggregation over 6 months, that's not a query that's going to return in under a second. In fact, depending on the size of the data set, that query might take several seconds or even a minute or two to complete. And historically, Elasticsearch and Kibana would simply time out, which wasn't good. Now with the new async search, what we have is the ability to convert a long-running search into an async model, and then the client can poll for the data. What this means, practically speaking, is that when you're in Kibana, no longer will your dashboards time out and fail to load all the data. Instead, what you'll see is something like the bottom where Kibana will pop up a little window and say, hey, your query is taking a while. Do you want me to continue running it in the background? And you just click on yes or run beyond timeout, and the query will continue to run in the background. And as partial results come in, the page will start to fill up. So I think this is a big usability improvement for our customers that are working with truly massive data sets. And we're excited to see where it goes. So we're just at the hour, a little bit over. That really covers what we wanted to go over. I'd like to take a moment to thank all the attendees and just open it up for final questions.
Maybe small question not covered here, but are there any improvements in scripted script support in the latest version? Since in my project we had to use some scripted metrics, and yeah, maybe some news on that front.
Did you have a particular issue with the scripted with scripting?
No,
or is there
no
something?
especially.
Okay.
Yeah. Yeah. go
we,
for it.
we have an exciting story around that. So as you know, Elasticsearch allows you to define a scripted field, which is you can write a script to synthesize new data from existing data. So maybe I want to do a regular expression match on a string and pull out a substring. I could do that with a scripted field. Or I could really do any arbitrary computation with a scripted field. What we're doing is what you'll see coming out probably in 7.10 in about 2 months, is we're going to start to release a new exciting feature called runtime fields. And runtime fields are really going to be the future of what scripted fields are today, but they're going to be more powerful. So you can think of the case where you might want to do some arbitrary manipulation on a field. Instead of doing it at index time, you can do it at query time. They're going to be more powerful than scripted fields, and they're going to be more efficient on the back end. And so this will allow you to do something like what Splunk does, where in Splunk today, when you query for data, you can set up a pipeline of data manipulations where you might grep something and then pipe that grep to a stat command and then sort it. With runtime fields, you're going to be able to do more of those query time manipulations without necessarily having to do any deep scripting.
Yeah, that sounds good. Thank you. Sounds great.
Sure. Then we have a question about how does async search differ from frozen index search? That's a great question. The truth of the matter is that the two would work well together. So frozen index search works by, the idea with a frozen index is that you've essentially closed the index and it's really offline. And when a query comes in for a frozen index, what Elastic will do is it will automatically open the index for you and then run the search. Now, this is a slow operation because it takes time to open the index and load those data structures into memory. So async search is going to work well with frozen search, with frozen indices, because pretty much by definition, frozen indices are going to take longer to query. And you usually are going to use frozen indices for older historical data that you might have going back several months or years. I hope that answers your question, John.
Oh, this is John. I asked the question. My question's more, I was more concerned about the memory consumption. So we've got a use case where we have to search like 10 years of content.
Okay.
Right. And today, yeah, that would time out and probably crash the cluster.
Okay.
So if we freeze them, then it takes it more slowly and doesn't have the memory requirements. Right. So I was just kind of curious, how did the async search really work, you know, compared to that frozen, where I know frozen, like you said, it opens it up and then, you know, searches one index at a time and it takes longer to search. The other thing about it, which is interesting, is you've reduced the heap requirements. So how, you know, do I really need to have frozen indexes now if the heap is a lot smaller?
Yeah, that's a great question. The memory improvements do lead naturally to questioning now how much indexes you want to keep open. I think that's the right question to ask. It will vary. The answer will vary for every use case. Your answer might differ from mine, but it does change that calculation. So you might want to revisit whether you actually freeze those indices.
Yeah, I mean, in our case, we don't, you know, we might be storing data for 10 years across that corpus, but we don't know in which of those indexes we'll be deleting data, because some data is held for 10 years, some is held for 1 year, some is 5 years, and they're all mixed together, right?
Okay.
So yeah, even with frozen, that means we have to keep, you know, thawing them out, removing documents, and then freezing them again when we have to do disposition. So yeah, so helping on that heap will, you know, lowering the heap requirements definitely is a big boost for us. just back to that async search, all it's doing is just taking longer to search. It doesn't, if I fired that query off on that huge corpus, right, would it search all in parallel and cause memory issues?
No, we don't expect it to cause memory issues because it is bringing back the partial results as they come in. So I think it would be good to try that. And now you can try it directly from Kibana with a query, and you'll get that pop-up window, that button that says you want to run beyond timeout, and you can just try it there. So normally async search wouldn't be something that you would directly use unless you're programmatically talking to Elastic. Rather, it's something that Kibana now understands how to utilize.
Yeah, I mean, we're talking directly to Elastic.
Oh, you are? Okay.
Our application is an archive of content, right? And so
okay.
We create our own queries and run against it. And like I said, there's some use cases where someone may want to search the whole corpus looking for a phrase or a custodian.
Okay.
And that could be very costly, right? And
yeah, absolutely.
If it takes a long time, if it's in a search 10 years, they just want the result and make sure the cluster doesn't go down.
Yeah, async search is going to be your friend there.
Okay.
And while doing async search, should I say it in advance that it should be async search, or it will be just the usual search that is just returning kind of request ID or something, and I can continue to query that?
There's a new API endpoint called async search.
Oh, yeah,
you would hit that instead of the traditional search endpoint.
Got it. Thank you.
Got it. Okay, great. All right. Well, thank you all. It's been a pleasure.